Today we are going to look at pointer operations. In this class, I'm going to show you why some religious congregations or ethnic group fear their children marrying into other congregations or into other ethnic groups. My channel is Religion, Science and Technology, and my goal is to use programming language to explain the language of religion, because I believe that the religious texts are actually programming codes. So let's look at pointer operations. The first one I'm going to show you will be what? The reference. The reference operator. The second one will be what? Pointer arithmetic. And then I will look at size of pointers. Right? So these are just the three things I'm going to show you under what? Pointer operations. So let's write our code immediately. So I'm going to declare a variable. I will say int body. This is the variable name, right? Int body, and I'm going to assign 10 to it. The moment I do this, this will be created. Memory location, address is 100. I'm assuming should be hexadecimal. So the name is what? Body. And then 10 is stored in this body. So this is a variable, right? And then this is address. Now I'm going to declare a pointer. A pointer is a variable that stores the address of another variable. So this is a pointer. This pointer also has an address. So let's give this address as 200. And then let's call this pointer soul. So this pointer is going to point to this guy, right? So what will the pointer hold? The pointer will hold 100. So this is a variable that is storing the address of another variable. The other variable is holding the actual value, which is what? 10. So how do you write this in programming? So I will say int asterisk soul, right? And then I will say body, address of body. So this is how to write it. Now I can say printf, %d, format specifier. Then I will say soul. So this one will now produce 10 outside. Why? Because of this guy. So this soul is what? The reference operator. So what is this one saying? What is simply saying is go to this location, which is this soul, that is this pointer, and then pull out the value that is in the address that this soul is holding. So when you get to soul, the address that soul is holding is 100. So you go to 100 and then use this guy, which is the reference operator, to pull out the value that is in that address. So the value in this address is what? 10. So to pull it out. So this will give me 10, display 10 outside, which means like your physical body that you are seeing, right? So this is pull out from a particular location, from an address. That is what you are seeing. So that is the concept of what? The reference operator. Now let's go into the second one, which is what? The pointer arithmetic. So you can use increment and decrement to move a pointer from one position address to another using pointer arithmetic. So to achieve that is I am going to declare an array. I'm going to declare an array, say int body again. I'm going to give the array name body. So I will do this, and I will do this, and I will say 1, 2, 3. Now, the reason why I didn't put anything inside here is because I declared the array and I initialized it at the same time. So the compiler knows that I'm just dealing with 3 elements. So I can now put 3 here if I want, right? I can put 3 here if I want. So that is okay. So I am having 3 elements. Now, I want to declare a pointer to point to this. So the moment I do this, what will happen? In the memory, this will be done. So 1 is here, 2 is stored here, 3 is stored here. So using index 6, 0, 1, 2. So the address of this will be what? 100. As an integer, the next address will be 104. I have taught you this in my previous classes. So this address will be what? 108. Because integer is what? 4 byte. 4 byte for what? Integer equals to 4 byte. So that is what has happened. Now I am going to declare a pointer to point to this. And then I'm going to use that pointer using pointer arithmetic to access all these values. So what will I do? I will come here and I'll say int pointer sol assign body. By writing the name of the array, so this is the array name body. By just writing the array name of the array, this will automatically resolve to the address of the first element. So the first element in this array is 1, and the address is 100. So it means this body is resolving to the address of this one. That is what it means. So this is the same thing as saying body equals to, right, address of body 0. So this is the same thing. So it's resolving to the address of the first element. Then I can now use pointer arithmetic to print. So if I want to print out this, first and foremost, I will say print f %d / n. Then I will say asterisk sol, right? And then I will close this. So this one will print out 1. Then I will say sol plus plus. Now this is a statement. So I'm using the increment operator. So this pointer arithmetic. So this is the same thing as saying sol equals to sol plus 1. Do you understand? So sol plus 1. Now, in the realm of mathematics, this means sol plus 1. And what is sol carrying? Sol is carrying the address. So this pointing to the first address. So it's carrying 100, right? Now, plus 1 should be what? Plus 1. That would be 101. But that is not so. In the pointer arithmetic, this plus 1 here is pointing to the data type, the size of integer. So the size of integer is 4. So this is the same thing as sol equals to sol plus 4. And sol is what? 100. So plus 4, that will be 104. And then you reassign it back to sol. So that means sol, which is a pointer, has moved from this one to this one. Now, if I want to access this value, I will say print f %d / n, comma, asterisk sol plus 1. To access 3, I will say print f %d / n asterisk sol plus 2. So with this, I can print out, this one will print out 1, this one will print out 2, this one will print out 3. So when I do this, if I say sol, let's remove this part. So with this, after doing this sol plus plus, and then I try to print out the value of sol, this one will give me 2. You see, I did this here. This one gave me 1. But because I've done this, meaning I've shifted the pointer to the what? To the next address. Now, trying to access that value of sol now will be what? 2. Because it did sol plus 4 and assign it back to sol. So sol is now carrying 104. So the value is going to be what? 2. That is what pointer arithmetic does. Right? Now, the last thing I want to show you is the size of the pointer. The size of the pointer. So if I declare a pointer int asterisk sol like this, now this is not pointing to anything. If I want to find the size of this pointer, I will say printf and then percentage lu, which is long unsigned integer. Then I will say size of sol. So with this one, I can find out the size of this sol. Now, the size of a pointer is not the size of the variable that it is pointing to. So the size of a pointer depends on the system architecture. So if I have a 32-bit system, right, it gives me pointer size as 4 bytes. If I have a 64-bit system, it gives me pointer size as what? 8 bytes. So it's very important. And now the reason why you have to know this pointer size is to be able to know how to determine your memory allocation, because even the pointer is carrying memory address. So if the system is 4 bytes, then you know that 200, which is the address of the pointer, is also going to be stored in 4 bytes. So the compiler will read just 4 bytes. So what happens when a man will leave his father and mother and be united to his wife, and the two shall become one flesh? He's talking about this kind of arithmetic. It's not 1 plus 1 equals to 2. It simply means alignment with the woman in the realm in which she's from. So ethnic group, each of them. So every woman from different ethnic group have their own data type. And you must be able to understand that in order to access the fullness of that woman, which is what? Alignment. So that's what I want to show you in this class. So the next class, I'm going to teach you pointers and array, which I have actually done here using the one-dimensional array. So the next class, I will teach you 2-dimensional arrays and then 3-dimensional arrays with pointers. So till we see in the next class. Bye-bye. So I'm just going to execute this program for you to see what will be printed out on the screen. So you can see this first one, printf, is going to print out what is inside the sol, and that is 1. Then I'm going to do pointer arithmetic, that is sol plus plus. Sol plus plus will move it to the address of 2, and then trying to print out the reference operator again on sol to print out 2. Then I'm using another format of pointer arithmetic, which is sol plus 1, right? And then I'm going to dereference. So at this point now, the pointer is on 2. Then when I'm doing sol plus 1, and then I'm dereferencing again, that will now print out 3. So it's going to print out 1, 2, 3. So let's run this for us to see. So you see, it's printing out 1, 2, 3, which is 1, 2, 3. That is what I want to show you in this class. So till we see in the next class. Bye-bye.